2, create performance task, make a plan. At the conclusion of this lesson, you will be able to describe the elements and purpose of the create performance task. You'll be able to describe the scoring guidelines for the create performance task and evaluate sample create performance task components by applying the scoring guidelines. All of this is in preparation to help you understand what you need to do so that you will be able to produce a product that will score extremely well. Now, warm up. Based on our review of the create performance task yesterday, last class, 2 days ago, whatever last class was, what are the main things that you have to do for the create performance task? And what should you do first? Can you name those things? You should. All right. A few of the things that you will need to do. You're going to need to write a program by yourself or possibly with a partner. You will need to make a video of your code running. You will need to answer written responses. You will need to make a PDF of your code. What should you do first? My goodness, pick and scope down your project. Looking at this create performance task, it sounds like this massive thing. Remember that you are not a graduate student creating a thesis. You're not going for your doctoral dissertation. This is a create performance task. You're going to show what you've learned, what you know. And it does not have to be massive. Now, what you're going to need is the create performance task survival guide. You can download it, print it off, whatever, from code.org. Now, optional, the task directions and the scoring guidelines, you should also have those available from last lesson, but they can come in handy now too. Now, task overview, page 1. For about 5 minutes, we're going to look at this page and see if there are any high level, I want you to read over page 1, sorry, of the survival guide and see if there are any high level questions. So pause the video, read it over. If you have questions that are not answered by the end of this lesson, please ask. Okay, you're back? Okay, some of the takeaways, or the takeaways that you should have gotten from that first page. First page had a lot of information, but these were the takeaways. 1, make sure your program has a user interface with both input and output. Takeaway 2, make sure your program creates and uses a list of information. Takeaway 3, make sure your program includes a function that has a parameter, an if statement, and a loop. Takeaway 4, use comments to cite any code, images, sounds, etc. that you or your partner did not create yourselves during the task. Now, what is required of your program? Okay, that's what we just went over. The 4 takeaways. Based on the 4 takeaways, it's clear that there are some very specific things you need, but you also have a lot of freedom in deciding on how to design your program. So before moving on, we're going to complete 2 short activities to make sure you really understand the 3rd requirement about functions, since that one is the most complicated. Now, function requirement activity 1, does it count? Look at pages 3 and 4 of your survival guide. Okay, review the scoring guidelines on page 3 and then decide if the functions on page 4 should be awarded each point, and be ready to discuss your reasons. If you're in class, we're going to have a discussion. If you're watching this on your own, I'm going to go over the answers. But pause the video and do this activity. Really important that you get familiar with this. You're back? Okay, so you be the AP reader. You are the AP reader trying to determine if the person who wrote this algorithm gets the point for rows 4 and 5. Assume each function below was submitted. For each, select whether rows 4 and 5 should be awarded and why or why not. No need for detailed explanation. Arrows to the code or short bullets are fine. So here's our first algorithm. Function repeat word, word times var return word is set to a null string. For I is set to 0. I less than times I plus plus. Return word is set to return word plus word return word. Will it get the point for row 4? Yes. A parameter is included that is used inside the function. Okay? Word is used inside the function, and times is used inside the function. Would it earn the point from row 5? No. The function does not include selection. It includes, it's got things in sequence, and it's got a loop or iteration, but it does not have selection. Algorithm 2, increase score points. Score is set to score plus 1. If score is greater than 10, end game. Calls a function called end game. Does it earn the points in row 4? Yes or no? No. The parameter is never used in the function. You can pass something, but if you don't use it in the function, if it's not integral to the function, it doesn't count. So just because it has a parameter, if it's not used in the function, it won't get the point. Does it earn the row 5? No. Okay, there's no loop. There's an if statement, but there's no loop. Example 3, function add list. List is passed. Var total is set to 0 for I less, or for I is set to 0, I less than list.length I plus plus. Total is set to total plus list sub I, and you return total. Again, the parameter, great. You pass it list and list gets used, we're good. Row 5, you need if, a loop, and statements. Nope, again, there's no if statement in algorithm 3. So you would get 4, you would not get row 5. And algorithm 4, add positives, and you're passed a list. Var total is set to 0, var current item. You have a loop that goes from I0 to the list length, incrementing the index by 1. Current item is set to the list sub I item. If current item is greater than 0, you're going to add it to the total. And you're going to continue that loop and then return. Earn row 4? Yes. Parameter is used inside the function. Earn row 5? Yes. Okay. Row 5 is a big yes because you've got sequence, you have a loop, and you have an if statement. So this one earns both points. The main takeaways from this activity. Some complicated looking functions may still not earn both rows if they are missing a component. Two functions may look very similar, but because of small differences, one will earn full credit while the other will not. The task only includes 6 total points, which are graded quickly by a very specific rubric. Knowing what the graders will be looking for gives you the best chance to demonstrate what you know. Right? If you go through it, if you went through those and you're able to pick out, I have a parameter that's used, great, within the function, I have an if, and I have a loop, then you've got those points. Function requirement activity 2, 2 function calls. We're going to practice here the response for 3D by coming up with 2 different calls to each function. And then you should be ready to talk through what you learned from the activity when you're in class. You should be able to explain it to somebody else if they ask. So pause the video now and do activity 2 in the survival guide. For those of you that aren't, oops, sorry, go back. For those of you that are doing this on your own, again, take about 10 minutes. And you're back? All right, the first function. This function finds the maximum value in a list and returns it. Now call 1 says find max 30, 20, 10. Call 2, find max is 10, 20, 30. Which condition runs differently? Okay, line 4. For call 1, this if statement will never read as true since the largest value is first in the list. For call 2, it will read as true for each element in the list. Each time that means line 5 will run updating the max value. Okay, 30 is going to be returned for both of these. 30 is returned for both of them. But notice again, what happens here, the largest is passed in. So if list sub 0, before you even go into the loop, list sub 0 goes into max. For this first one, that's 30. So I'm going to loop through, and max will never be updated within the list. On the other one, max is going to constantly get updated. Now, I don't know why that hit there. And next one, end game. We're going to check end game with 90 and check end game with 110. So notice that if the score is greater than 100, we're going to go through a loop 3 times and set this property. If it's not greater than 100, you won't go through the loop. You'll just go to end game. Okay? So we've got 90 and we've got 110, one that's below and one that's above. The if statement on line 2 will evaluate. Notice, oops, when it's stating stuff, we're passing the line number, okay? The if statement in line 2 will evaluate to true for call 2, but not call 1. As a result, for call 2, all of the lines 3 through 6 will run. For result 1, nothing happens since the score is below 100. The result of call 2, all of the enemies are hidden and the game is ended. Okay? So if the score is greater than 100, you're going to hide these enemies and end the game. The score is less, we're not going to enter the if statement, and it's just going to end the function. The function is going to do nothing. Next, just so you know, that activity is designed to help you anticipate how you will need to respond to prompt 3D and potentially make some decisions about how to design your functions. Here's some things you may have noticed. It is much more straightforward to answer the question in the second example since the parameter is being used directly in the conditional statement. In either case, one should come up with example arguments that run differently from one another, that run through different parts of the code, and you should be able to identify the line number where that split happens. Okay, so when you're responding, when you're doing your response to 3D, you want to be able to give your 2 calls, explain the condition by stating the line number. Where does it change? Here's where this is being checked, and it's going to go one way, and it's going to do this for this instance and the other for another instance. Now, narrow it down. Page 6. Why narrow it down? You should assume that you're not going to have enough time to complete the perfect project for the create performance task. While 12 hours may seem like a very long time, the majority of your score actually is based on your written responses, and it turns out that even many small or simple projects meet all of the requirements listed. You will be better set up for success if you narrow down your project. This is not the end-all be-all. How to narrow it down? Narrowing it down means taking a larger idea for your create task and finding the smallest version of it that will still meet the task requirements. Here's some ways to do that. Identify your function and list early. Start out with a clear idea of how you'll hit the minimum requirements of your list and your function. You need to have a list of something, and you're going to do stuff with that list, and you need a function. And it's probably a good idea if the function does something to the list. Okay? Pick one part of a bigger idea. Often your original big idea can be broken down into smaller ones that meet the requirements of the task. You may want to have something that will just hand the world over. Break it down. Do just one part of your big idea. You can always add on to it later if you want. Minimal design mode. Looks don't matter. Complex visual design work in design mode, setting colors and fonts and spacing, will likely not meet any of the requirements of the Create Performance task. Please do not worry how your app looks until after you have already have the code that will let you complete the written responses. Okay, so bare minimum. Think about when you go sometimes, if you've ever seen the Disney movies and they show you the sketches, okay, when they sketch out a cartoon, they don't put in all the detail. There's not all the color and the richness. It's a sketch. Your design mode, your input screen, leave it very basic. It can be black and white. You may need some buttons, input text box, output text box. You might need something, but don't get crazy about making it look pretty until you've got everything else, until you've got the functionality there. Have it just kind of white it out. You can go back in and add colors and add pictures after. Don't worry about that in the beginning. Don't spend a lot of time doing that. It's not going to get you points. Practice narrowing it down. We're going to do a little bit of practice for 10 minutes. You've got some examples on pages 6 and 7. What I want you to do is brainstorm ways that the student who's developing those could narrow down their ideas. So let's try it. First, before I show you the answers, pause the video, take 10 minutes, and pick one of them. You don't have to do all of them, but within 10 minutes, do at least one, maybe even start on a second one. All right, tic-tac-toe. Here's my idea. I want to build a tic-tac-toe game. The user creates an account if they don't already have one and are taken to the main game board. From there, the player will play against the computer in either easy, intermediate, or advanced mode. So I will need to write the code for the computer player. When the game is over, their lifetime win total is updated. I will also keep track of how long the game took. Okay, list and function opportunities. List opportunities, the names of people logging into the app, the positions played in tic-tac-toe, lists of the win totals or how long each historical game took. Function opportunities, functions to check user names and decide if you can get logged in, functions to check if someone has won the game of tic-tac-toe, functions to update and check the win totals or game length. Now, this is a big project. May not sound like much, but it's big. Build just the login screen. Build an app that can just detect a win, loss, continue condition in tic-tac-toe. Design a way to keep track of scores over time. Demonstrate a single example of how a computer would choose its next move based on a board set up. Don't use tic-tac-toe, but a simpler game. Pick a number, okay? Pick a number game. Tic-tac-toe is very complicated, believe it or not. Build the user tools that would appear around the game, not the game itself. Those are all ways to narrow down this project and get all the points. The next one is a health app. I volunteer at my local health clinic, so I want to build a health app. The user can record information about what they eat, how much they sleep, how much exercise, and information like their blood pressure and weight. Based on the information provided, the app will provide recommendations to the user about how they can improve their health for both diet and exercise. Users can also personalize the look of the app with different different theme colors. Okay, ways to narrow it down. Don't track as much information. Ask for a couple of pieces of information and make a single recommendation. Don't personalize themes or colors. Only provide recommendations for diet or for exercise. There's no need to provide recommendations for both. Remember, time. Focus on the core recommendation portion of the app. First, don't worry about the other screens until that piece of code is written. List opportunities. List of what people eat, when they exercise, their blood pressure. You can have a list of any one of those things, okay? Or any of those things. Function opportunities. Any function that processes one of the lists above will likely need to include all the necessary components since it will traverse the list of health data being stored and then select something make a decision based on what the value is. Sports stats. I think that I'll build an app that allows the user to quickly record stats during a basketball game. The app will show a picture of the court. The user taps on the court to indicate something happened there. They are presented with a quick menu of options like shot attempt, foul, steal, rebound, etc. Then they select from another list which player did it. And at the end of the game, it displays a stat sheet for all of the players and the stats for the game. Okay, only track a single statistic at first. For example, shots. Just track shots. Or fouls as proof of a concept. Keep the total number of statistics simple. Example, just a count of shots. Only keep a track of statistics for one team or even on one side of the court, offense or defense. Keep the app to 2 screens, one for showing shots, fouls, etc. so far, and one for showing summary stats. Avoid adding extra features at first, like an ability to delete statistics added incorrectly. You list opportunities. Any single piece of information this app would track will likely be stored in a list. An example, the shots, the attempts. Function, any processing of the information above will likely need to be a function that includes a parameter, a loop, and an if statement. Because you're going to loop through the list looking for something that's a particular value. So you pass the list, you loop. If it meets that value, you do something with it. Now, understand, it doesn't have to be a big project. The create performance task is about demonstrating something you already know how to do. The biggest thing to guard against is your eyes being bigger than your stomachs. I want to encourage you to be creative and start to build whatever you want. But please temper that with the realities of the create task, the time constraint that you're under. It doesn't need to be a big project. Your job is to demonstrate that you know how to program something and identify certain aspects of it. Remember that there are no points for coolness or prettiness. Being too cute, too sly, not going to earn you points. If you want to do something big, just get it started in the create performance task and come back to it afterward. Choosing a project idea. You should now understand how the create performance task works, and you should be ready to start brainstorming some projects. While you have at least 12 class hours to complete the task, keep in mind that those 12 hours, you must also make your video and complete the written responses. It is recommended to budget at least 5 hours to complete the video and the written responses, and so it's highly recommended that you prepare to do a project in which the programming coding can be completed in 6 to 7 hours. Some things you want to think about. Personally relevant. Pick a project that you are actually interested in building. Clear purpose. Aim for a simple program whose purpose can be stated in one sentence. For example, the purpose of my program is blank. My program lets a user blank. Narrowed down. Repeat the narrow it down process with your own ideas. A good rule of thumb is that you'll want to be able to have a first draft of your algorithm within 2 hours of starting your program. No new programming skills. Make sure you already have enough of the programming skills necessary to complete the project. Be flexible. With some creativity, you can likely use the skills you've already learned to make your programs, okay? You can make lots of different types of projects. Avoid taking on new programming environments or concepts as part of the create task. You're just asking for trouble. Choosing a project. Page 8. The main takeaways here. You don't actually have that much time to work. When you start, you should have an idea about what your list and function will be. Start with a narrow scoped project and start working right away. Do not wait till the end. Start working on the core parts of it, the big pieces. Creating the list, building the list, processing the list. Don't try to learn any new programming skills during the performance task. Do something you already know how to do. Okay, page 8. Spend about 5 minutes thinking up 2 project ideas you could do for the create performance task. Let's take about 5 minutes and just brainstorm some ideas of what could you write a program about. You're back? We're going to wrap it up. The Create Performance Task Written Response Organizer. So take a look at this organizer. You're going to use it throughout your project to make sure you have all the components. Program purpose. Right here, write down, doesn't have to be a complete sentence, just jot down, what is the purpose? Your list. What's the name of your list? What type of information are you storing? Where do you create the list? Where do you process the list? How does it manage complexity? And again, this can be bullet items. This is so that when you go back and you write your response to this, you can pull from here. My list's name is, it holds this kind of information, okay, and so on. Your function that includes a parameter, if statement, and loop. Okay, what it does, think about the experience of the user. How it does it, think about how the code actually works. So the user's experience, how the code works. 3D, 2 different calls, what's being checked, and the result of each call. Now, we're going to take a look at a timeline. You good. Okay. You guys are good. I just have to go and get oh my goodness, sorry about that. I guess you just have to fast forward through that. So you've got this timeline. This is a suggested timeline. During hours 1 and 2, you should begin building a program for a project you brainstormed. Carefully monitor whether you will finish enough of your project in time. You should be confident after the first round of development that you're going to meet your requirements. For hours 3 and 4, keep working. Check in after hour 4 once again on whether you are on track to complete the responses. You should ideally know the abstraction you will write about, the algorithm you will write about. 5 and 7, finalize all programming. So after 2 weeks, probably by Monday of the 3rd week, all your programming should be done. At this point, you should avoid adding any new features and focus only on debugging and cleaning up your existing code. So the end of the 2nd week, beginning of the 3rd week. Then on hour 8, you need to record the video of your program running and complete response 3A. That should take an hour. Your video is 1 minute, so it shouldn't take that long, but sometimes it takes a while to actually successfully get a video. Then hour 9, complete 3B, describing your list and how it is used. Hour 10, complete 3C, describing your selected function. 11, complete 3D, describing 2 different calls to your function, what's being checked, and the output of each call. Hour 12, complete the task. Review the submission materials. Make sure you've got everything together. Check your responses against the scoring guidelines. Do a quick go through. Be hard on yourself. Upload your video, written response, and program code to the digital portfolio. Goal, at the end of this day, your Create Performance task is submitted and 30% of your AP score is done. It's done. Now, the timeline. You want to review the calendar and review it often. What did you notice about how the schedule recommends you spend your time? You want to maximize writing, video, and code PDF time. Coding time that is not focused on making your function or list is likely not well spent. It doesn't matter if your program looks good. It just needs to work. Doesn't matter if it looks good, just work. Don't forget to allocate time to proofread for those easy to make mistakes that will cost points. Like, forgetting to cite sources. At the bottom of it, put cite sources. Did I cite all my sources? When in doubt, cite it. Use the response checklist and the survival guide to make sure you'll earn all the points. Are you ready? We are almost there. One last lesson, and then you will be cut loose to perform.